I'm Orv, W6BI, Southern California. Been into digital since like forever. Been messing around with ham radio networking for the last, gosh, almost 7 years now. So I'll be talking about what I've learned, what you can do with it, and what you can't do with it. First, I want to talk about data rates. These are modulation rates, not throughput. If you've ever, back in the old days, used a 56K dial-up modem, you know you didn't get 56 kilobits end to end. And the same thing goes with packet radio, 1200 baud. And with the modulation they use, 1 baud is 1 bit per second. And in modern terms, that's 0.0012 megabits per second. It wasn't especially fast 35 years ago, and it hasn't improved any since. PACTOR 4, which is the fastest PACTOR, is about a little over 5 kilobits per second for PACTOR 4. VARA is a relatively new modulation scheme done in software. On FM with the right radios and interface, it can do up to 25 kilobits per second. But the ham radio network links under optimum conditions can be more than 100 megabits per second. So you can see they're obviously quite a bit faster. The AREDN software, as of today, it was derived from the OpenWRT open source router software, which is in itself derived from Linux. It currently supports 4 different brands of equipment, 70 different models across 4 ham bands. And if you happen to be in an RF black hole, you can tunnel between your node to another node that is on the network and then thus get network access. The software knows how to move the radios in the access points out of the part 15 channels into the adjacent part 97 ham radio only channels. And as you can imagine, the noise level is quite a bit lower there, which helps a lot. The software supports MIMO, which is multiple input, multiple output, and I'll talk a little more about that, plus 802.11n, which is the sweet spot for long-haul wireless operation. They have a DNS and DHCP server built in. They do route discovery and routing information, and all of those 3 in bold make it a lot easier to get a ham radio network going. You don't need a lot of extensive network knowledge. So when the software is loaded, they call them nodes. They use stock wireless access points. You don't have to do a lot of hacking on them. The 4 brands they support are Ubiquiti, TP-Link, MikroTik, and GL.iNet. Ubiquiti and MikroTik are by far the most popular versions. When you put AREDN software on them, they go out and locate each other and figure out routing, and they create an IP network. You have to kind of consider them like handy talkies. They're low power, usually around 600 milliwatts. And they're limited to line of sight. What that means is that usually, like a handy talkie, you usually end up talking through a high-level site, a hilltop or mountaintop. And I hit the wrong button. There we go. And if your node here is multiple access points on multiple hilltops, it will always choose the strongest one due to the routing algorithm. So there's really no point in running an omni antenna. You might as well focus all of your RF energy at the best link. This is an old graphic I found quite a few years ago, and I've updated it to show the improved performance of modern hardware, but still can't do those trees. And because of where you guys live in Maine, I've thrown in a bit of content I'll show later for some workarounds. So you've put up this wonderful ham radio network, but it's just infrastructure. Just like the internet, it doesn't do anything. It just gets you to places where you can use things. And those services are the stuff you see on the screen here: web servers, email, video, and pretty much anything else you can think of that might be useful, subject to the Part 97 regulations. I'm going to show some examples here. These are things we've tried in Southern California. Some of them we don't use, some of them we still use. And you're not limited to these. Anything, use your imagination. If it looks useful in your area, give it a shot. Communication hubs are things like Slack, if you've ever used that at work, or in ham radio for that matter. Mattermost and Rocket Chat are open source Slack wannabes. They include, like Slack, text and pictures. You can set up multiple channels. You can access them via a web server, or there are apps for all the popular OSs. This is our Meshlink, or excuse me, our Mattermost server here in Southern California, Ventura County. This is a screenshot you can see from Eric, KG6WXC. He and his family were out camping in the high desert the evening of the 7.1 earthquake near Ridgecrest. They got bounced around a lot, but when you're in a tent, there's nothing to fall down on you. The next day he drove over and took a picture of the surface rupture and posted it on our Mattermost server. Now out in the high desert, we don't have any mesh network coverage, but there is wireless coverage. And because he runs two Mattermost servers, one on the internet, one on the MeshNet, and they're tied together, he was able to use his cell phone and post it on Mattermost, and we were able to see it on the mesh network. It's very handy. Voice over IP, everybody knows about VoIP phones now. This picture is about 7 years old now. When we were deploying the mesh network here, we wanted to put up a VoIP server, a VoIP PBX, but at the time, the guy who was deploying the network didn't have enough confidence in Linux. In fact, he didn't know anything about it at that time to deploy something like Asterisk or Free PBX. So he bought a turnkey PBX from Grandstream. I don't know what model this is. It's about $250. Has far more capability than we need, and we deployed that. And you can see it in the repeater rack here in the red oval, I guess. This is up on Sulphur Mountain near Ojai, California. At this point in time, there are about 30 active extensions on it. A lot of those are hams, but anywhere we deploy a mesh network to a served agency, police, fire, hospitals, we'll give them a mesh network, a mesh phone, and give them an extension on the PBX. We deployed other servers, but before that, because it's a Grandstream PBX, around here we recommend people use Grandstream phones. They integrate better. You can manage them better. You can push firmware updates out. And here you can see I missed a call, and I have one call waiting in voicemail. They have all the features you'd expect: call forwarding, conference bridges, which we use occasionally. Second PBX we deployed was Free PBX on a Raspberry Pi 3. This is on Verdugo Peak in the next valley over to the east, tied together with mesh, the mesh network. And the two PBXs are trunked together, and I've given each one of them kind of a pseudo area code. There's currently about a dozen users on this PBX, and they can dial users on the first PBX by preceding their extension with their area code. We have, I think, 2 or 3 other PBXs in the area on the mesh network that will get trunked eventually. So collaboration servers are the kind of things you've seen the gamers use on TV or in the movies, where they coordinate their teams and movements. Programs like TeamSpeak, Mumble, Teamtalk. If you look on Wikipedia, there's a list of a couple dozen of them. We chose, they all have the roughly the same number of features: voice and video chat, file sharing, desktop sharing. We chose Teamtalk. It's one of the few collaboration servers that doesn't mandate encryption, so we got to avoid that whole discussion. Its features: many-to-many chat rooms, one-on-one chats. You can go off and talk to somebody privately. And you can set up as many channels as necessary. You can use, if you have a laptop with a built-in speaker or microphone, you can use that, or a USB headset works well. These are full duplex connections. This is not like talking to someone on a repeater where you have to wait for them to say over, where you can finally talk. You can actually interrupt someone in mid-conversation. It's a lot more like natural speech. And if you have multiple conversations going on multiple channels, they can all go on at the same time. And if the links are all good, the codecs on each end will upshift as much as they can in quality. That means this is not your 300 to 3000 hertz communications grade FM repeater channel. The quality can be excellent. We have a weekly net, and I'll close the doors in the office here, put on a headset, turn on Vox, put my feet up on the table and just have a natural conversation. It can be just like the person's in the same room with you. It's very nice. Over and above Vox, you can use push to talk, just assign a key on the keyboard. Or you can use an open mic where you have a nailed up connection from one point to another. We've not used this, but you could imagine it being used in an emergency situation, from a fire camp to a base camp. You set up a couple laptops on a private channel on the server, nail them up together, put them in a quiet area, and somebody can run up to the laptop and say, hey, I need to talk to Bill. The other end will say, stand by, I'll go get him. Very natural. And it doesn't chew up a lot of bandwidth. Typically, a voice channel is about 30 kilobits per second. Our mesh network end-to-end across the county depends on the day, but it'll support anywhere between 3 and 5, maybe as much as 7 megabits per second. So not a big deal. This is an older screenshot of a Wednesday night net, and you can see the number of people logged in on the left. And when a person talks, the background behind their name and call sign turns green, and when they unkey, it turns yellow. So you can see that Dave KM6FQ was the last one to talk. Across the top, you see tabs for chat, video, desktops, and files. And here's another later net. We don't find that video adds a lot, but it's good to have. Once in a while, we'll have everybody fire up their cameras to do a stress test on the server and the network. It always helps to know how well things are running, so you'll know you'll have them in an emergency. Let me see. The 3 on the left are here in town, Simi Valley. Middle right, Glendora, about 50 miles away to the east. Port Hueneme in the middle, about 50 miles to the west. Bottom is, where is Dale? Cathedral City out near Palm Springs. That's about 100 miles away. And Kevin in the upper right is in Culver City down in near West Los Angeles. And anyway, typically the client here is configured for 640 by 480 resolution, maybe 10 to 15 frames per second. And configured that way, each video stream's about, I don't know, around 100 kilobits per second, depending on how much motion there is in the frame. So we've got, because this isn't multi-stream, it's just point to point, we have 7 streams at 100 kilobits up to the server and 7 streams back down for a total of 1.4 megabits per second, and it ran fine. If you're interested, the server is a Raspberry Pi 3, and during this test, CPU averaged about 10% utilization, and its network utilization was also about 10%. It's a nice tool to have. Down at the lower left, you can see aux channel 1 and 2. That's just what I named them. If a couple guys wanted to talk privately, they could double click on those channels and move over there and talk privately, independent of the rest of whatever was going on the server. When they were done, they would just double click on the root channel up at the top and return to the main channel. It's a nice tool to have. The other use of video is cameras. I'll talk a little bit about this one because this is kind of what kicked it off. In 2016, when the AREDN software had matured enough to start building backbones. We were building a backbone across our county from hilltop to hilltop, and then adding user access points on those hills and building out the network. On this particular hilltop, which is Sulphur Mountain, we threw up a junker camera just to experiment with. And that was late September 2016. And a few weeks later, another tech specialist in the area, Ben AI6YR, you may recognize the call sign. He got a lot of press by helping locate a lost hiker in the area recently. But anyway, he sent me a link to an article on how to stream webcams to YouTube. I figured it out and showed him a stream of my test camera showing my driveway. And he told me to put it away for emergency use if we ever had need for it. Well, less than 8 weeks later, this fire broke out, the Thomas Fire, near Thomas Aquinas College, Santa Paula, California. That day it was hot and windy. Fire broke out around 6. He pinged me. I was able to get the camera up there streaming, and as luck would have it, it was pointing at the origin of the fire as we watched it come over the hill. We were able to stream it for a couple hours, and at that time we lost a midway link due to power loss. The winds were blowing so hard that Edison lost power. Subsequent to losing the stream, the fire came down that hill there, took out the owner's driveway gate and light, and proceeded right to left, I don't know, 50 or 60 yards in front of the tower, proceeded west and just ripped up the town of Ventura. They lost hundreds of houses. We lost power after that, even though we had solar and battery there, because the ash from the fire covered up all the solar cells. So lessons learned, battery backup everywhere, pan-tilt zoom cameras everywhere. And since then, we've been working towards that. 11 months later, the Woolsey fire broke out. It broke out in Woolsey Canyon, which is about 3 screens off to the left of what you're looking there on the LA Ventura County border. And again, a hot, windy day, and the fire proceeded left to right. And this camera, which happens to be on the north edge of my valley, is looking southwest at the southwest corner of my valley, and you can see the fire there. It headed down those hills and threatened that part of the town. Then the wind turned and it headed back over the hills south down into the town of Thousand Oaks, ripped it up, went through Malibu, tore it up, and stopped when it got to the Pacific Ocean. We streamed this for 36 hours. Ben AI6YR, who I've mentioned, is very big into emergency communications, has a large Twitter following in the area who follow him with information about fires, earthquakes, and whatever. And he posted the YouTube URL, and over that 36 hours, we had hundreds of people checking in and out to watch the fire. And the feedback we got that it was obviously more timely than what they were seeing through conventional media. Since then, we've streamed a number of smaller fires. This one happened to be right at the base of the hill that the camera was on, small one by the freeway that goes into my my town. If you look closely at the bottom, you can see the guys in the strike team that were dropped off by a previous helicopter. So video is very important in our area for showing any incident. You don't need to stream constantly, just need to have it when available. So messaging, since it's a standard IP network, you can set up any kind of email server you want using, it all uses standard SMTP for, message transport. And you could use things like Thunderbird as your client, or web clients on a server. Roundcube has matured a lot. It's very, very good. And I'm going to talk some about Winlink, because Winlink and the mesh network are a match made in heaven. And I'll talk a lot more about that. If you're not familiar with Winlink, it was originally made for boaters to keep in contact. On HF, it originally only supported ALE radios, commercial frequency agile radios, quite pricey. And over the years, they've added packet radio, robust packet, which I had to look up, is proprietary to SCS, which is the vendor that builds the Pactor modems. I mentioned VARA as a software modem, substantially less expensive than a Pactor box, but under many conditions will outperform even Pactor 4. Very cost effective. RDOP is another software modem. Its previous generation doesn't do nearly as well as on HF as VARA does. On VHF, you've got packet radio. You can send through APRS, VARA FM, which I mentioned, which is again a software modem. And recently, I guess it's been a couple years now, they added support for AREDN networking, specific support. And as you'd expect, it's substantially faster. And to boot, you don't have to worry about digipeating. The network knows the route to the destination. Again, if you're not familiar with Winlink, it comes with a large library of canned templates you can fill out and send. Incident command system, USGS and FEMA, plus there's room for local standardized templates. We use one for ACS check-ins every Tuesday night. I stole this off the Winlink website. They haven't updated it in a long time, so I used my awful graphic skills to update it. Down at the bottom, WinMore has been deprecated, no longer supported. I've added VARA and RDOP on HF. VHF, I've added VARA and showed that that's where the ham radio networking goes. Again, if you're not familiar with Winlink, this is the client, Winlink Express. Looks a lot like standard email, but behind the screens, it can be more complex because depending on what path and what protocol you're going to send, you have to route it, address it, and route it differently, depending on whether it goes packet, mesh, out to an HF gateway or whatever. I wanted to show this. If you're familiar with Winlink, this is a session screen. You open one to send out email, and there's a different one for each protocol. This one happens to be over the mesh network. Typically, Winlink will forbid you from sending an attachment larger than about 20 kilobits, 20 kilobytes, and because it could take forever to send that via HF. But I sent this to the nearest Winlink post office. It was 3 network links away. And you can see I sent 22 kbytes about for a total start, send, and finish time of 10 seconds. Not too shabby. Not even VARA FM can keep up with that. You can also do RoIP, repeater over IP linking. If you've got a couple analog repeaters you'd like to tie together on hilltops and their line of sight to each other, these units from JPS or SkyMira can link them together over Ethernet. And they don't care if it's a wired cable, the internet, or in this case, mesh networking. They'll transfer all the necessary signals back and forth. I have no experience with them. I'm told they're fairly pricey, but you can get them on eBay considerably cheaper, and it's got to be cheaper than a pair of 420 UHF linking repeaters. And since All-Star, D-Star, and DMR can be linked via Ethernet, you can tie them together via the mesh network. And I understand, I'm not into any of those, but I understand some of the guys farther east in LA County are starting to do that. Other things you can do. This is a screenshot of my weather station. My weather station is a Pete Brothers Altimeter 2100, and it just has a console, but fortunately it has a serial port on the side. So I ran that into a USB converter and into a Raspberry Pi, and the Raspberry Pi sits on the mesh network in my shack, and the software is called WeWX, WEEWX, from WeWX.com. Runs on pretty much any OS and supports pretty much any weather instrument under the sun. Very versatile. We have 3 of them running in the area. It's kind of fun to compare them. It's not all about MCOM. We run a Scrabble server at times. That was fun. Also a tank game, shoot 'em up. I end up losing all the time. And after the Wednesday night net, once in a while, we'll play a few hands of Texas Hold'em. So whatever you can think of. Eric KG6WXC, who I've mentioned, wrote a network crawler program. It's a mesh mapper. It goes out and pulls out of each node a file. It's a JSON file, like a text file, of all the vital information from that node, and stores it in a database. And if the node has the latitude and longitude configured in, he can map it. The software is open source, so I don't know, I think there's about 12.5 sites around the world running it, and I've managed to capture screenshots from some of them. This is Whatcom County, Washington. They've only been up about 6 months. They're doing pretty well. This is Oregon. The colors indicate the channels, the bands. Orange is 5 gig. I always have to think about this. Purple is 2 gig. Purple is 2 gig. Blue is 3 gig. Pink is 900 megs. So you can see them using that here. And gray is no RF connection. And I'll talk about why that might be. Hawaiian Islands have been up about a year. Obviously they have challenges with all the mountains, but they're doing pretty well. As of the last time I checked with Jesse, all of their inter-island links were internet links, but they're actively working to establish RF links. Chad KA7HAK has built this thing out over the last 3 years. He's got 5 gig linking the mountains, and just recently he's put cameras up on a couple of them, and he got to video his first brush fire a few months ago. This is a San Francisco wireless emergency mesh network. This network's about 3 years old now. They're doing a really good job of deploying it. They've got a good plan. They're working at expanding it south along the peninsula and farther east. City of San Francisco has been very accommodating to them, letting them have almost unlimited access to any city building or other structure. So they've had real good luck. This is my home stomping ground, Southern California. We got a head start because a couple of the AREDN team live in Southern California. Plus there's a lot more hams in Southern California than most places. And we have a lot of mountains. Last time I looked, there were about 400 nodes in the area shown here. Let's talk about what's available. The hardware supported by AREDN is designed for the most part for outdoor use. There are some exceptions. So they're weatherproof and they're power over Ethernet. There's 4 pairs and an Ethernet cable. 2 are used for data and the other 2 are used for power and ground. I'm amazed at how inexpensively you can buy the sophisticated electronics that are in these things. There's 2 software-defined transceivers and 2 modems in each box. That's for MIMO, multiple input, multiple output. What that means is they divide the data stream into 2 streams, transmit them simultaneously on the same channel, one vertically polarized and one horizontally polarized, and they combine them back together at the receiving end. It's pretty amazing. Most of them have gain antennas, one for vertical, one for horizontal. And as you'd expect, the throughput and sensitivity are far better than the older gear. Just a couple of heads up here. I mentioned that the AREDN software is based on OpenWRT, and as time goes on, like any other software, the OpenWRT software gradually grows in size. So the AREDN software also grows in size, and at some point in time, OpenWRT is going to stop supporting the older devices that only have 8 megs of flash and 32 megs of RAM. If they stop supporting them, it doesn't mean they'll stop running AREDN. It means that the newer AREDN versions won't be able to be upgraded onto those older devices. So just be careful. And if they only have one end connector on them, they're not MIMO, they don't mix well, and they don't work as well. And also, when you try and run a CISO, SISO, single input, single output against a MIMO device, they don't play well together. If you're concerned, this is kind of says a list of devices that aren't recommended. What they have is a list of supported devices on ardenmesh.org. And the ones that are not recommending for new purchase are flagged there. Those are the ones you want to avoid if you're shopping. They work fine right now. So anyway, back before AREDN, it was broadband Hamnet, and this is what they supported. Linksys WRT54G. I think it's 4 megs of flash and 4 megs of RAM, something like that. Obviously not weatherproof. And I mentioned the 600 milliwatts of power average. This thing is 60 milliwatts, so you're 10 dB down right there. And in spite of having 2 antenna connectors, it does not support MIMO, nor does it support 802.11n. So AREDN was when they, well, I'll avoid the politics. Let's just say AREDN moved forward with the Ubiquiti gear from then, and there's where they started. These are the nano stations, the M2 for 2 gigs and the M5 for 5 gigs. They work very, very well for line of sight up to about a dozen miles. I'll talk about why, if you were in a suburban area, you might not want to buy an M5 as a new purchase. I'll talk about why that might be later. On the left, you have the Ubiquiti PowerBeams for 5 gigs in the 300, 400, and the 620 millimeters scare your neighbor size, each with, as you'd expect, increasingly higher gain and narrower beam width. On the right is the MikroTik equivalents, large head grid 5 XL and or 5 HP and 5 HP XL. They've become very, very popular, especially with those guys who have been backfitting their Go kits with the digital capabilities because they're very, very light because of the plastic hex reinforcement behind the grid there. And additionally, the wind loading is quite a bit less. The only knock I've heard about them is that if you live in an area with heavy icing, that might not be what you'd want to put up. Obviously, this is not an outside device. This is a MikroTik 5-port router. And it's pretty much the second thing everybody who gets into mesh networking buys because it's so useful in the shack. So when loaded with software in your Ham Shac, this is what it does for you. The AREDN software runs on the 10.0.0.0 network, can't be moved. And typically nobody runs that at home. You're 192.168. Whatever, which means you'd have to run 2 separate computers in your shack. And that's what you had to do until this little thing came along and AREDN started supporting it. What it does is it combines the two. Anything on ports 2, 3, or 4 in the diagram there has access to your home network and the ham radio network. It routes them appropriately. And if anybody's wondering, yes, it's appropriately firewalled. It has a bunch of other really useful features. And if you're going to wind up tunneling into the internet, this is what you need to buy, or tunneling into the rest of the mesh network. Some screenshots of some typical home installations. They're all over the map, as you'd expect. On the left, a couple of nano stations for 2 and 5 gigs. And why would he have that? Well, at the site he links to 3.5 miles away, they have 2 gig and 5 gig user access points. If one of those goes down, he still has connectivity. It's redundancy. At any served agency that we install mesh networking at, if we have an opportunity to put this kind of redundancy in, we do. On the right, KM6PTE has run a nano station and a MikroTik, and I didn't mention it, but the MikroTiks have 2 Ethernet ports. If you enable them, you can run the cable from your shack up to the main port, run out the secondary port to another node. That way you can pass through both data and PoE power, and you still only have to run 1 cable up the mast. I keep hitting the wrong button. Geez. Okay, if you, I don't know if you have HOA, homeowner associations in Maine. but they tend to be really strict about outside antennas, but they're required to let you put up a satellite antenna. So if you throw a MikroTik Light Dish Feed 5 up at the feed point of an old satellite antenna and put it up, you're on the air. They'll probably never notice you're not pointed at a synchronous satellite. A lot of the stuff I've mentioned already, like a handy talkie, wouldn't be appropriate for integration into a hilltop site. This is mostly what you see up there. This is a Ubiquiti sector antenna. It's called a sector antenna because it radiates at a given number of degrees in the compass. This one's 120 degree, which is the most popular type. Again, there's two antennas up there inside that, 120 degrees vertically polarized, 120 degrees horizontally polarized. And if you look closely at the back, you can see the two coax jumpers going into the top of a Ubiquiti Rocket M5 of 5 gigahertz. It's got the two chains, they call them transceiver chains in there to illuminate both of the antennas. And at a site where you need to cover more than 120 degrees, you would not use an Omni. You'd use two of these overlapping on two separate channels to minimize interference and tie them together with an Ethernet switch down at the base. So, okay, some sites. This is, I call it a small site, but it's fairly sophisticated. Joe has sector antennas for 2 gigs, 3 gigs, and 5 gigs. This is in North Orange County, California, and it's looking mostly south. He's got a pan-tilt zoom camera at the top and a fixed bullet camera at the bottom, looking back behind us at the solar cells, the solar panels, and battery. This particular site is solar powered because it's a 1/4 mile hike off the nearest dirt road. This is one of the sites I take care of. It's a medium-sized site. The sector antennas there. There's one for 2.4 gig part 15 that has nothing to do with us. I have 2.4 gig and 5 gig sector antennas for mesh network access. The small dish is a test dish. Up at the top of the mast is a UHF, or excuse me, VHF antenna for repeater. And on the container off to the left, all the stuff on the left side of the container is county. We don't care about that. And then there's a UHF 4-pole there. The large dish on the tower points west back into our county, and that's our backbone link. To go east, you can't see it here, but at the base of the antenna, there's conduit with Ethernet going up the hill to a larger installation on the right with another dish on a container up there pointing east. That connects to the 3 gig dish here facing us. This site is on Verdugo Peak above Burbank, California. It's about 16, 17 miles away. It's pretty impressive, but only a small part of it is mesh networking. This belongs to DARN, the Disaster Amateur Radio Network. They have 26 sites in Southern California with, I don't know, I lose track, 41 repeaters. Most of the gear here is theirs. They were very gracious in letting us write on their microwave link. Anyway, there are 3 sector antennas here, 5 gigs pointing west and south and 2 gigs pointing west. The dishes on the telephone pole link to sites farther to the east. And if you're curious, this photo was taken right after a really bad windstorm, and the HF remote vertical's since been repaired. Okay, you genuinely call this a large site. This is a commercial site on Pleasants Peak in Orange County. The owner's ham friendly, and one of the ardent developers lives very close to this. Over the last 5 or 6 years, he's added this stuff shown in yellow for mesh network stuff. Not shown down below the picture are dish antennas pointing at 3 or 4 points of the compass to link various backbones together. This is a major hub. So you need line of sight coverage. If you need to know if 2 sites see each other, there's various ways to do it online. HeyWhat'sThat.com is good for quick and dirty. Airlink.ui.com is Ubiquiti's site. It's pretty easy. RadioFresnel.com works very well. And radio mobile lets you get very, very deep into it. Some of the guys really like it. So let's talk about the bands. We have 900, 2.4 gig, 3 gig, and 5 gig. We don't use 900 a lot around here in suburban areas because not only do we only have a 5 megahertz wide channel on 900 megs, we share it with every smart electrical meter, gas meter, I don't know, whatever kind of meters you have. And it tends to be quite noisy. Out away from the cities, it could be quite useful. Over and above that, the gear tends to be fairly pricey. Oh, and I'll talk about the other ones later. So this is some Ubiquiti 900 meg gear. This is a Ubiquiti Rocket M9 with a dual polarized Yagi. I don't know that they manufacture this anymore. If you wanted it, you could probably find it on eBay. This is a 1 watt 900 meg data radio, good for about a megabit per second. A WISP gave a box of this stuff to a local ham who gave it to me. I've got 2 of them talking to each other, and I will probably eventually deploy them as a back channel up to our local mountaintop 6 miles away. I just did a quick and dirty search, and the amplifier, the radio itself, is, when you can find them on eBay, they're about 90 bucks. So NPR is new packet radio. This is something that's come along in the last 2 years. It's a 420, a UHF radio that's a bridged IP network, optimized for point to multipoint. I just got that off their webpage. They say they'll do up to 500 kilobits per second, and you can add an amp for up to 20 watts. Some of the guys on the AREDN forums are playing with this and deploying it, and I know they've had dialogue with the author to smooth out its operation across a mesh network. It's obviously you wouldn't want to run video across here, but if you've got 2 mesh network islands and you need to link them together through a lot of trees, this might be a useful item. And again, $80 per end. And again, that's the radio. You've got the antennas, the cable, etc. We all know that. Anyway, here's a screenshot of it. It's sold at, he is having Elakitsorparts.com sell them. I'm not sure if they're actually kits or completely built. I have not played with them myself. F4 HDK was the guy who invented them.
Whether you can get both, either a kit or assembled, it's only $10 difference. Good
to know. If it were me, I'd buy them pre-assembled. And here's a setup where they were testing them. Horizontal polarization, that makes sense. And I think he's got an amplifier down there. So that would be something to consider where you have a lot of trees. In Maine, I would say make friends with all your repeater operators and talk them into how useful it is to have digital links between their sites. So on 2.4 and 3 gigs, on 2.4 in about 2013, about 2013, the AREDN software gained the ability to move out of the shared band. You know, the ham band goes up to channel 6. We were in here in CME, we were using channel 1, and on a 3-mile link, I was getting, I don't know, less than 75% link quality to another guy. When the beta code came out, we were able to move out. We both moved down to channel -2, and the link quality both directions went way above 90%. Obviously much quieter. We're not deploying much on 2.4 gigs anymore because there's only one channel. You can't build cells, and it's still got a bit of splatter from the part 15 stuff. If you're out in the boonies, you could probably even think about making a double wide channel and using channel -1. 3 gigs works very, very well. That's the good news because it's all ours. The bad news is the FCC will be taking part of it away, and maybe the rest of it in the future. We'll see. Stuff's fairly pricey because there's no Part 15 in the US on 3 gigs. So we had to buy all European gear. And as a result, it's getting scarce and quite expensive. So if and when they do pull 3 gigs out from under us, I'll have to throw away $1,500 worth of gear and move over to 5 gigs. Okay, here's 5 gigs. This is all ham radio, top to bottom, shared. The orange down there says ham band. That isn't quite true. We were secondary in those channels to the Department of Transportation for the last, I don't know, 7 or 8 years. FCC gave it to them primary to develop a vehicle to vehicle protocol. But they never did anything with it, and the FCC got impatient with them and yanked it away from it. I think there's litigation on that, but I think it's going to stand. So what the FCC has said they're going to do is let the unlicensed channels expand down up to channel 184. Additionally, they're talking about one other unlicensed but not Part 15 service in there. So what will happen over time if that happens is in our channels, you'll gradually see the noise level rise. So if you're going to buy some new 5 gig gear, and you're in a suburban area anyway, I would recommend buying more gain than you think you need, kind of future-proof, because you can't have too much gain. It isn't all that expensive. So where do you get ham radio info? Ham radio network info? AREDNmesh.org is the website. They have, as you expect, the list of supported products, software downloads, both production and nightly builds. It says nightly, but they don't come out nightly. They only put out a production build about once a year. And over the year, as they add new products, support, bug fixes, minor enhancements, those go into the nightly builds. So quite a few of us run the nightly builds. Every nightly build is just an incremental change and really, really benign. And some, if you want to run the new gear, you might have to use them, but they're available there. A whole bunch of how-tos, FAQs as you expect. And Steve, AB7PA over the last 2 years has taken and all the documentation he could find, put his arms around it, put it in a GitHub repository, and now it's there and it's become very excellent. There's forums, not only forums about bug reports and deployment issues and questions. They also have regional forums on a per state or per country basis. And if there isn't one there for Maine, I don't know if there is or not, you can ask Randy, the webmaster, to create one. And that's a good place to post information on local activity. There's a Facebook group that's unofficial, but it has over 1,500 members and it's fairly active. There's a lot of information on AREDN, but the little asterisk there is for me to remind you that if you find something there that's more than maybe 3 years at the most out of date, give it a pass and find something more current. We're going to try and see if we can get some of the videos about putting broadband Hamnet on WRT 54Gs taken down and kind of reduce the noise level. We'll see how that goes. I have a beginner's guide PDF I'm happy to send anybody if you want to distribute it to your members. Or I have a much more voluminous version of this presentation because I'm not time limited. I added some more documentation there and I'm always updating it. Any questions? I know I ripped through that, but
well, thank you very much. That was amazing to see the diversity offered. I mean, I'm in awe of everything. I mean, you won me over at Texas Hold'em Tuesday nights now. We're going to have some nets on that. That was pretty cool. So I think there's a lot of options for us to use and plenty for everyone. So that was really cool.
I got to thinking of my time in Maine and all of the forests and said, well, that could be challenging. But you do have hills and you do have high level repeaters, and there are some options for pushing stuff through in vegetation. So you guys can use your imagination.
Yeah, we certainly have a long road ahead, but we're up for the challenge. I think it's going to be a worthwhile adventure. You know, for MCOM, for the regular casual chatting, for all the other things that you asked. I think that was really cool, the concept of the 2 pseudo area codes. Now, was that done as an experiment, or was there a capability limit that made you do that?
Well, they're physically distant and they service 2 different ham radio communities. Now, there is a push to create some sort of nationwide dialing plan for mesh phones. N2MH is pushing that hard, and he's got a lot of people on it. Down in Southern California, farther southeast of us, they're talking about some sort of local band plan. Personally, I'm not convinced that it's necessary because emergencies are local. And honestly, the future of MCOM is data, not voice. So if somebody wants to join our little PBX network, that's fine. If not, that's fine too. The 3 PBXs that we will eventually have tied together cover, I don't know, 400 or 500 square miles already. So honestly, you move your data via Winlink, because nobody wants to write down 30 medicine names on a piece of paper and then try and repeat them over to somebody else when you can move it in a minute or 2.
Absolutely.
And you get one letter wrong and it's different chemical.
Oh yeah, you're in trouble. So anyway, this is good stuff. My focus is the infrastructure. I'm not so much into the MCOM. So I have a Winlink gateway here set up and stuff, but insofar as deploying in the field, I'm about 30 years past that. I'll let the younger guys do that.
Do we have other questions that you would like to ask of Orv?
Just to say, Orv, thanks. This is great stuff, and I'd love to have both of your PDFs if you don't mind sharing those.
I don't mind at all. Corey, I'll send you the small one and a link to the big one because it's too large to email. And I need
Excellent.
to freshen it. It's about a month and a half out of date. Every time I give one of these presentations, I go over it and give it little tweaks. So I have to go back and update the PDF version. And it's
Excellent.
on Facebook, by the way.
Great. Anyone with any last questions that you might have? Any lingering questions you've always wanted to ask about mesh?
So yeah, I kept it under an hour.
That was great. Thank
Excellent.
you for that.
I'm excited to see the activity here. Thank you, Corey, for reaching out to him. I stumbled across you on Facebook ages ago, like, hey, that we should do this in Maine, and finally we found a crew.
Yeah, and I dropped the ball. I should have done that like a week and a half ago, but I forgot. And thanks to Orv for being so flexible on quick turnaround with that.
You're welcome. Just a quick pointer, going across lakes or going from seaport to seaport, if you've got line of sight, is a good way to get started. And just as a rule of thumb, I always was told our longest link here was 45 miles, mountaintop to mountaintop, which isn't too shabby. But I had Eric pull a report out of the database, and he found 2 locally that were 60 and 61 miles respectively.
Wow.
Yeah. Now, just a quick heads up, because of the timing of the protocol, the farther you go, the slower you have to slow down. So, but still, 5 megabits per second ain't too shabby.
Compared to 1200 baud.
Oh, sorry. I'm trying to get all the Winlinkers off a packet here. It's just a struggle.
Any final questions?
Thanks for having me, guys.
Well, thank you, Orv. I appreciate it. Oh,
Thank you. That was
Hey,
great.
this is
Bill. Yes, go ahead.
hey, I'm actually driving around, but I've been listening and watching, and it was a great presentation. It really reinforces the foundational stuff that I've already started to work on for the past year here with the few mesh network nodes that we have up and running in the Brunswick, Maine area. And Teamtalk is up and running, and I've got some open source monitoring tools, monitoring the mesh nodes that we have. And I just got in some new packet devices that you talked about that I need to test and play with and so on and so forth. But it was really good, great overview, and I appreciate that.
I still don't have a clue how you bridge 2 islands with those bridging things because I would think you'd have to route, but I'm sure you guys can figure it out.
Yeah, that's probably going to be a challenge, and I look forward to it. It'll be fun.
Yeah, the guys in the forum are really, really smart, and there's 4 or 5 of them who have been working with those radios for close to 2 years now. So you could probably get any questions answered there.
Yeah, the forum is great. Every time I ask a question, I'll get 4 or 5 answers, and it really helps. So it's
Hopefully
a great
one of
place to
them's
get-
right.
Oh, no, they're all good, and they look at it at different angles depending on what they've done and their experience. So it's been good. I've also got BPQ node regular packet tied in to the mesh. So there's a lot of opportunity to tie a lot of things together. I like the Winlink idea too, since I act as a gateway for that on packet. Certainly very interesting thoughts.
Good deal. Okay, guys, I'm out of here. Thanks a lot.
Thank you, Orv.
Thank you, sir.